The Yamaha 4C is one of the most common beginner mouthpieces, and in this video I'll be modifying pretty much everything about it so that it plays much more like a modern jazz mouthpiece. The main point of this video is to try to use as many advanced mouthpiece refacing techniques as possible to transform this piece into something that plays totally different. This should be an interesting challenge, but still not as difficult as carving a mouthpiece out of a solid block of material, which I've done in these earlier videos on my channel. Okay, so for this piece, my main goals are to open the tip from 60 thousandths to 110 using both bias cutting and standard tip opening, lengthening the facing curve from 40 to 50, adding an epoxy step baffle, and dialing in the baffle profile with my custom 3D printed measuring tools, as well as more general steps like creating a thin tip rail with the final baffle shape, reshaping the tip to match the reed, reshaping the body to correct for the bias cut table flare, general polishing and cleanup, and then A/B testing at the end of the video. On a close first inspection, you'll notice that the tip rail is very thick, and looking down into the mouthpiece, you can see how the baffle shape is a slight concave, which I'm going to change dramatically. The tip opening is extremely closed at 60 thousandths, which I'm going to try to open all the way to 110. And the facing curve is a short 20 millimeters, or 40 on this standard half millimeter scale. But I would say the most defining feature of this mouthpiece is that it's $35, which is an important detail to consider when doing something like this. Now, you might be wondering why I just did that, and what I'm going to do with $17.50 worth of mouthpiece. Well, now I can take a picture of this centerline profile and import it into my Fusion CAD software to more accurately design the shape of that epoxy baffle that I'm going to add. So to calibrate the CAD software picture, I just need to take a total length measurement of this. Okay, so here's my picture, which I've inserted as a canvas in Fusion. So now I just have to calibrate it, and I'm going to add the first point on this side, right here. Now the second point about here, and I'll make that 106.85. So now this should be properly sized. This line here at this angle, this is actually the tip rail, or the cross section of the halfway point of the tip rail. So that's what we can use to then reference how concave this baffle is. If we draw a straight line from the inner edge of that tip rail down to about here, you should be able to see how it's actually a little bit concave in the middle here. Yeah, that looks a little bit better, so I think I'm happy with this design now. It's still a long step baffle, but now I've just lowered the steepness here into the chamber, which will make it a little bit easier, I think, to make. Okay, so now I have all these measurements plotted out. I'll zoom in here. So each of these vertical lines is 2 millimeters apart, and each one will give me, on the tip gauge reading, how far down I need to measure in order for the baffle to be this shape. Okay, so here's that planned baffle profile put into the graph. So this top line is that planned step baffle, and this bottom line is the current 4C baffle. So basically what we're looking at here is from this perspective, where this line here is the table, and this is the tip opening. The mouthpiece is this way, but way zoomed in. So basically this in-between area here, this triangle, is the shape of the profile of that epoxy wedge that I'm going to add. So on this graph, all these points here are individual millimeters, so this is very zoomed in. So the maximum thickness of the epoxy that I'm going to add is about 5 millimeters from here to here, which compared to the actual size of the mouthpiece, doesn't look all that extreme, so you can see right around here on the inside, that depth of change of the baffle is pretty significant. So this is my 3D printed baffle grapher tool, which I'm going to use with all these points to measure the mouthpiece. So for this project, I'm only going to be using this for the centerline baffle measuring instead of the full 3D baffle measuring that it can actually do. But if you want a full explanation on how this tool works, you should watch this video first because that explains it in more detail. So before I start sanding this, just take a note of how wide the table is at the base here. And that's going to be changing dramatically as I tilt the table down. This is going to flare out pretty significantly. Okay, so on the actual piece now, the first thing I'm going to look at is the tip arc. You could call it the frontal rail arc here, which actually looks pretty good in relation to the reed. But what I'm going to do is sand it just a little bit because it's a little bit round, just the way this plastic piece was formed. It's a little bit overly round this way, and I want a bit more flat definition to it, just on that arc. That looks pretty close, actually. I'll be bringing the corners in a little bit more as I go, but that's enough for now. And you can see, compared to the reed here, the end of the table is really narrow. So I'd normally do most of my table and facing work at 800, working on up to about 1500 grit. But on this, I'm actually going to be starting at 180. Just because the amount of material I have to remove here is pretty extreme, which is kind of why I called the video that, just because it's a really big change that I'm making in terms of tip opening and the amount of material that I'm taking off. I can't really do that all at 800, it would take forever, so I would have to start at 180. So here's just a final look at the stock surface finish of the table. And as I'm doing this table tilting, I'm just going to use a couple feeler gauges from this set, because as I'm moving this so dramatically, there's a very high chance that it will kind of wander side to side like this, which will show up in the facing, straightness. So I can use those gauges to measure against the stock facing here, and that will tell me if I'm wandering one way or the other, and it'll be able to keep it pretty straight, hopefully, as I move this back. And if not, then I can adjust it based on those gauges. So again, we were starting at 60 thousandths, about. And I'll be measuring the tip opening pretty frequently as I tilt the table back to see the progress. So it's kind of a tricky balancing act, because I'm basically trying to tilt it back, I guess you could call it from the fulcrum of the end of the facing length. Because if I just pushed it back, normally flat, it would just be closing the tip opening instead of opening it from this point, which is what I'm trying to do this way. Okay, here we go. Now, first table pulls. Also, my voice might get a little muffled here. It's time for this dust mask to go on, because this is plastic dust. It's really fine and pretty nasty stuff. So let's see where we're at now with the tip opening. It's at 81. So it's moving. So maybe I should have explained this earlier, but the main point of the bias cut table tilting is that we don't have to remove that much material going from 60 to 110, my end goal. We don't have to remove all that material from the tip, because it's really not there. You'd be ending up cutting way back into the mouthpiece. So this way, I'm going to first move the table back, tilting it probably until I get to around 105, maybe a little bit less, and then do the normal tip opening from there. Because there's just not that much material here for me to open it that far, so I need to take it off the back first. 84. Use the alcohol spray. You can see how that unclogs it pretty quickly, actually. And anytime you're dealing with a lot of dust like this, or even a little bit, you have to be really careful about getting dust caught between the work surface and the bottom of the sandpaper. That can give you a lot of issues and bad surface finish in the table, especially later on. So I am noticing the table's rocking a little bit back and forth, which means it's not completely flat anymore. So I'm going to do some normal table pulls instead of tilting it back, just to kind of even it out before I keep going. So now to check the table straightness, I'm just going to use the 010 and the 024 right now. The 0015 is going to be way too sensitive for this kind of really rough table work. It's not really that useful of a measurement right now, so we're very crooked right now, which is kind of expected. This is the first measuring. So basically what that means, if the gauge is like this, that means this side of the table needs to be brought down this way, because the table tilting down this way will force the gauge to be more square up this way as the table is brought this way, but also back. So it's a kind of complicated three-dimensional balancing act with this table moving. So another tip opening check. We're at about 87, 86, 87. You can probably tell the table is getting quite a lot wider from where we started. And now it's at 100 thousandths, with the base of the table now just wider than the reed. So I'm going to keep tilting the table back until it gets to around 105. And then from there, I'm actually going to go in and put in the epoxy. So the tip opening is just around 105 now. Still 105 thousandths open. And the table doesn't have any noticeable rocking to it, which is good. And now checking the side-to-side levelness of the table. The 010 is pretty much a dead-on 40. Just ever so slightly longer on the right side, but almost perfect. And the 024 is just about a dead-on 30. It's now definitely close enough for just basically regular refacing techniques. You know, table flattening, a little bit of back and forth evening if I need to, and then the facing I have literally not touched at all. So from this point, basically, it's kind of hard to see the actual textural transition here, but this area here I have not sanded at all. It's 100% stock, the tip rail and the rails. Now let me grab another stock one just to compare it to. Okay, so we have a stock 4C on the left, and obviously the one I've been working on the right. You can really see what a huge difference it's made on that table. And you can even tell, just by looking at them side on like this, it's actually a lot easier to see with a white background. So this is the stock one on top, and the modified one on the bottom. Again, pay attention to this part right here. Can you see what a noticeable difference that is, how much material's been taken off this one? And I'm actually very happy with how symmetrical this curved part is there. Actually looks quite nice. Now before I start the next part, which is going to be working on the epoxy baffle, I thought I'd actually compare the table angles on these, because they should be different now, because that's what I've been changing, obviously. So I have this digital angle caliper. I think that's what it's called. So on the stock mouthpiece, let's put it up against here. Looks about 94.1. And this modified one. 92. So there's basically a 2-degree difference, but obviously 2 degrees does quite a lot. If it looks like this, and it's opened it from 60 to 105. Okay, so now it's time to start working on the epoxy baffle, and for that I'm going to use this stuff, which is Epoxy Sculpt. This is one of the most amazing and versatile materials I've ever used, by far. I used to use this stuff a lot for modifying Rubik's Cubes. I used to be very into puzzle designing and modifying. And I actually still have another YouTube channel called SMB Puzzles, which I used to post stuff on, but I just haven't in a while because I don't have time anymore really for that stuff. But you can check it out if you want. I used to make stuff like this. So all these puzzles here were modified from pretty much standard looking Rubik's Cubes using this exact material and other ABS plastic sheeting. So this was just the time in my life where my Rubik's Cube hobby turned into me being an expert at Rubik's Cube designing and modifying. I don't know, it's hard to explain. But basically I've used this material a lot. It's amazing and very versatile, and I will be using it on this. And before I add it, just one other note. You can see right here that very faint transition. That's actually the transition between the sanded material from the table and the unmodified facing. So that's that transition. That's basically the facing length right there. It's probably very hard to see. So I would consider Epoxy Sculpt to be a pretty forgiving material. It sticks to most things, but it does help if you roughen up the surface a little bit. It just gives it a little bit more to grab onto. A little bit easier to see from this side. So this is the height of the epoxy I need to add. So basically 24 millimeters back from the tip, it needs to be at least this high. So about 5 millimeters down from the plane of the table. So that's just my rough guideline, that I need to at least have that much there. And I'll probably put quite a lot more than that. This stuff can sand away pretty quickly, so I'm not concerned about overfilling it. So to work with this epoxy, I'm going to put a piece of plastic down just because I don't want to put it right on this towel to get any, kind of lint and other dust on it. So there's my part B. That looks to be about equal. And now you mix these two together. And I do want to make sure that I'm filling all the way up to these corners here. And it's actually okay if I go a little bit over the tip rail and mess that area up because I'm just going to sand it away anyway. And turns out I'm basically just filling up the entire volume, which I'm actually okay with because then I know I have enough. And I'll just have a little bit more to sand away. So I think this is looking pretty good. Now I should let this cure at least overnight, probably 24 hours. If I do need to do another round of epoxy, that's fine. But this might actually do it, depending on how deep I actually need to go. I'll see once I start sanding it. So I think that looks pretty good for now. I will let this dry at least overnight, and I'll see how it looks tomorrow. Okay, it's one day later now, and the epoxy is fully cured. So I think it'll be interesting if I graph out the height of the epoxy right now before I start filing into it, just to see how much material I actually have to remove. Okay, so measuring every 2 millimeters, here's my points, and I'll put it on the graph. Okay, so this top pencil line is the current epoxy baffle height. The middle one is the planned finished baffle height, and then of course the bottom one is the stock baffle height. Alright, so as I start filing this down, the main thing I'm going to be looking for is the 24 millimeters back from the tip point that, my end goal is basically 5 millimeters down. So as I'm filing this down, I've made a quick reference here, just 12 millimeters back and 24 millimeters back from the tip, so that I know how much material I need to take off. So that'll be a quicker way for me to make these rough first measurements rather than putting it on the tool each time. So the numbers I'll be looking out for at 24 millimeters back, it needs to be 4.8 millimeters down from the table plane, and at 12 it needs to be 3.5. So 3.5 and 4.8 are the numbers that I'll be looking for. So here's what it's currently looking like up close. If you can see on the inside of the rail here, there's a very thin piece of epoxy that runs up the side. So I need to file this down, hopefully without actually adjusting the size of this rail. Hopefully you can see what area I was targeting there, this inside edge of the rail. It's not done, but it's a lot more cleaned up than it was. Okay, here's what it's looking like up close again. And to give you a quick idea for what the surface is going to look like later, I'm going to give it a quick sanding sponge just so you can see how much smoother this material gets. So after just a couple passes with the sanding sponges, you can see how much smoother that's going to be later. So having just temporarily smoothed out the whole baffle, this is probably a good opportunity to put it back on the baffle grapher tool and redraw this line so we can actually see what progress I've made. Okay, so here's the new graphed out line. So this top line here that I've kind of halfway erased, that was the original epoxy put in without any sanding. Now this current line here, this dark pencil line, that's where we're at, and this line here is the target. So of course the original baffle, the end target, this is where I am now, which is pretty much exactly halfway between where the epoxy was put in and the target. Okay, so now that the baffle is about halfway down to my target height, I'm actually going to change gears a little bit and work on the table. From what I said before about it flaring out a lot, you can see if I put a reed in the center of the table how much wider it is. So what I'm actually going to do now is just trim down the sides of the body here so that the reed fits a little bit better. So I'm just going to lightly mark out the width of the reed and then using a file from the outside bring that back in. So those lines are pretty faint. I'm not really sure if you can see that. I might actually put some blue tape on the inside of that just so I can have something more visual to file to. So you can see just a tiny sliver of the table that I have left to go, compared to the left side, which I haven't started yet. So that's enough filing and sanding for the right side now. You can see how this has been blended back. So now that that's done, the table looks much more normal. And if we check with the reed fit looks almost perfect from both sides. And especially here, you can notice that that table flare has been pretty much completely taken out. So the transition point at the 24mm mark needs to be 4.8, and we're at 4.16. So that 4.8 target is now 4.67, so it's getting pretty close. And at that halfway point, at 12mm, it should be 3.5, and it's 3.46. If we look up here near the tip rail, you can actually see that this lighter material here, this is the epoxy, and then this is the, ABS or whatever plastic the mouthpiece is made of, and then the same material, but on the tip rail. So these two surfaces here are basically the stock mouthpiece, and then this is the epoxy baffle. So on the final result, you might see some sort of texture or color transition between the actual plastic and the epoxy, but there's not much I can do about that. This will actually become a lot darker, as you probably saw when I smoothed it out before. But I'm not really too concerned about that. Once the tip rail is properly formed, and in the light, the tip rail will kind of glow differently from the baffle, and it'll have plenty of definition. I'm not too concerned about the color transition there, but just something to point out. So this is still not the final shape, but you can see how it's a little bit more straight across there. And looking in from the front, you can tell that it's actually pretty even left to right in terms of comparing it to the table. Okay, so now I'm actually going to be working on the table and the facing, getting that to kind of a rough draft version of that. And then once that's pretty close, I'll go back to basically finalizing the baffle shape, and then will be the final refacing, final tip rail work, and then cleanup after that. So for the table, I'm going to start at 400 grit, basically just to clean up the heavier marks from the table tilting and make sure it's totally flat. And then I'll go up to 800 and then start working on the facing. Okay, that looks smooth enough for now, so I'll move up to 800. So those table pulls there to reflatten it brought it back down to 100, but that's okay. It can still be open to 110 pretty easily. Okay, the first gauge, the 0015, is actually almost at 48. It's like a crooked 47, 48, so that's not that far away. So there's still a bit of crookedness in the facing curve, but a lot of the points are actually pretty close. So I'm going to move up to 1500 grit and see how close I can get from there. So the bottom of the facing is actually a lot closer to where it needs to be than near the tip area, so, and I still have to open it quite a bit, so I'll go back to 800 at least for this section. The tip opening is now 103. And now it's back to 105 thousandths. And you can see the tip rail has gotten really thick, which I'll have to correct for. So the first gauge is sitting at a fairly even 46. I'd like to get that down to 50. Hopefully you can see that the surface finish on the table looks pretty nice now. So the first gauge is now a pretty much dead even 48. Just a little short of what I want, but at least it's even. Okay, now I'm going to go over to the buffing wheel to clean up these areas here. So all those filing marks have been polished out. So now I'm going to go back to opening the tip to the final measurement and doing some final table and facing work. So right now the tip opening is at 106. .5. And now I'll do the finishing work at 3000. There it is, 110. There's a nice even 50 length facing. Okay, that facing is now done. So there's the final surface finish for the table and the facing and the tip rail there. Of course, the tip rail is still very thick right now, which will be brought down to size with the final baffle filing. Okay, off camera I just checked that the baffle is now at the target height. So really all that's left to do is the final baffle and tip rail shaping, and then some just minor cleanup after that. Okay, after about 10 more minutes of off-camera baffle work, the piece is now complete. Like I mentioned earlier in the video, you can see how much darker the epoxy actually gets when it's fully sanded smooth. And then this slight color transition right here is the original plastic of the mouthpiece here, and then the epoxy. And I'll zoom in on some other angles so you can see the tip rail and baffle in more detail. So hopefully you can see now that the tip rail has a nice thin shape with good definition. I would say overall I'm really happy with the surface finish, other than there's a couple little dots here and there, and these are just little tiny air pockets from the epoxy. It's kind of impossible to get it 100% perfect, so I did clean up a lot of those as I went. But this is just about as nice of a surface finish as you can expect without doing 10 more rounds of epoxy. And from the other side you can see the baffle looks very even. And checking to see that the tip rail glows in the light like that, separate from the baffle and the other parts, is really important. Hopefully you can see that it's quite thin with good definition, but not overly razor thin. And a comparison next to the stock mouthpiece. So here's another look at a stock 4C and this modified one. The table here being very different, and of course the baffle. And another side-by-side before and after tip rail. Okay, so now for the playtest on both of these. This will be a little bit more of a systematic A-B playtesting than normal. So I'll be focusing on things like overall volume, how they subtone, how they staccato, how much you can bend them, their overall flexibility like that. And of course, they're going to sound very different because of the baffle, but the main difference you'll notice is that this one plays significantly louder than this, and that's due to the tip opening, of course. And I went back and forth quite a lot thinking about how I should do this test, because the tip opening being so different, this is a 60, around 60 thousandths, this is now 110. They have extremely different resistances, so for a while I couldn't decide whether I should use different reeds, but I'm actually settling on using the same reed just because I want to eliminate as many variables as possible. The only thing that's changing is the mouthpiece. It'll be the same horn, same mic distance, and also very importantly, same mic gain, because this one, as you'll notice, the stock one plays way quieter than the new one. So the reed that I'll be using is a D'Addario 4 Soft, which is basically the softest reed strength that I can play on a 60 tip opening without it just completely closing off and not being able to work at all. It is a little bit stiff on this opening, but I'm actually kind of used to playing setups like that, so it's actually a pretty doable comparison for me, at least resistance-wise. Because if I also changed reed strengths dramatically, I think that would just create too much variability between them.